Okay, so I'm going to work through the selected questions from the paper 1 from last summer, from the May 22 session. Now this is slightly different from the other papers that we've been working on, in that because of COVID it was a reduced syllabus and the paper was only out of 70 rather than usual 80. So I've shared the grade boundaries, but these are out of 70 and out of 140 rather than out of 160. Okay, and we're going to be able to access questions 1 to 8 and 12 to 15 based on the work that we've been doing. Question 1. You'll be assessed on the quality of your organisation, communication and accuracy in this question. So this is the OCW, where you just need to be a little bit organised and clear with units in the work that you're doing. So ABC is a straight road, where the ratio of A to B and B to C is 3 to 4. A to C, so the whole distance from A to C is 56 kilometres, and the first thing we need to do is work out the length of BC. So AC is the total distance, so this isn't one where one of these is equal to 56, the whole lot. So we've got 7 parts, and we need to divide that 56 into 7. So one part will be 56 divided by 7, which you should be able to do just from your times tables. It's 8. So A to B will be 3 lots of 8, and B to C will be 4 lots of 8, which is 32. So BC is 32, and that's going to be kilometres, because the distance that we've divided is in kilometres. This question is asking for the answer in miles. So this is one of the few metric to imperial equivalents that you need to know. You need to know that 8 kilometres is approximately, that little squiggly equal sign means approximately 5 miles. So 32 kilometres, we've just got to think about now, what do we have to multiply 8 by to make 32? 4. So miles would also be 4 as well. So 32 kilometres is 20 miles. So the 4 marks for that, you're going to have 2 marks for working out 32 kilometres. So a method for finding one part and multiplying by 4, and then there'll be a method mark for remembering and applying the right metric to imperial equivalence, and then finally one answer. And for the +2 for the organisation, it's just laying out your work. So it's clear there that I've worked with that ratio to get one part, then I've multiplied to get those. That's BC. I'm using consistent units, kilometres, and then kilometres and miles, and finally 20 miles. So it's not about essay writing. So wrong place. Table below shows some of the values of x squared, y equals x squared plus x minus 4, values of x from 3 to -3. So we've got to plot that. Will I fit it all on? Mostly. Okay, so part A asks us to complete the table, but what I suggest when we did this, and the ones that we've done since in class, is to plot the ones that you know, because it'll give you an idea about whether or not you're going to do the maths right for those two. So I'm going to plot -3, 2, so the first number x, second number y, -3, 2, -2, -2, leave the -1 for now, 0, -4, leave the 1, 2, 2, and 3, 8. Now it's an x squared curve, so you're expecting it to look like a U shape. So when it comes to x is -1, to keep that U shape going, I'm looking for -1 to be somewhere down there. So I'm looking for a negative answer, maybe -3, maybe -4 to keep that going. And then 1 will probably also be a negative number. And again, maybe around -2. So that's just to give us a sense of what we should expect out of our maths. So we want to work out if x is -1 in this, what the corresponding y value will be. So we take x equals -1 and we put it into that. So where there's a letter x, we replace it with the value -1. And when we're replacing a letter by a value, we put it in brackets. So we get that. Now -1 squared is -1 times -1. 1 times 1 is 1. Minus times a minus. The answer is, so the sign's different, so the answer is positive. So that's going to equal 1. And then I go plus times a minus is a minus. 1 take away 4. So I've got 1 take away 1 is 0. Take away another 4, -4. So -1 is going to be -4, and that fits with my curve, so I'm happy with that. Then I have to work out x equals 1, y equals 1 squared plus 1 minus 4. 1 times 1 is 1, plus 1, take away 4. 1 plus 1 is 2, take away 4, minus 2. So 1 is -2. So we've got our 2 marks for correctly working those out. On the opposite graph paper opposite, draw the graph of y equals x squared plus x minus 4 for values of x between -3 and 3. So I've plotted the points. That would be a P1. Now I have to draw the curve. You use a pencil, you do not use a ruler, and when we've done this in class, I've shown you how to turn your graph paper upside down so your wrist is on the inside of the curve that you're going to draw. So you don't join these up with a straight line. We're looking for a curve like that. Don't go straight across at the bottom. Just go with the flow of the curve. It's going to be slightly lower than that somewhere. So that's my C1. Use your graph to solve the equation x squared plus x minus 4 equals 0. Well, we've got x squared plus x minus 4 equals y. That's what we have plotted. So the y, we're looking for where y equals 0. So we draw the line y equals 0, and the line y equals 0 is this. It's actually the x-axis. This is where the y coordinate is 0. So the x-axis is y equals 0, and the solution to the equation will be where the curve crosses the axis. So on this one it's going to be minus 2.6 and 1.6. Now because you're drawing that graph freehand, your curve might be slightly different. The one I did in class earlier, I think I had 1.7. So they will allow you that degree of tolerance when reading off that. And there's 1 mark for that, so you need to get both of those values correctly read off. Question 3. The children in Year 5 and Year 6 in the primary school took part in a survey. The children were asked, how many pets do you have? The results are shown in the pie chart and bar chart below. No child in either year had more than 5 pets. So I got, for Year 5, I've got a pie chart showing that information, and I know there are 36 children in Year 5, so that pie chart represents 36 kids. One child is chosen at random from all the children in Year 5 and Year 6. What is the probability that this child has no more than 1 pet? So if it's probability, we've got a fraction. On the bottom of the fraction, are the number of pupils in total, and the number on the top of the fraction would be the number of pupils with 0 or 1 pet. So I've got a bit of work to do now. I'll leave the pie chart till last because that's a bit more complicated, but if we deal with year 6, it's represented by a bar chart. I don't know how many are in year 6, so we can find that out. There are 6 with no pets, 8 with 1 pet, 5 with 2, 3 with 3, 2 with 4, and 1 with 5. So if I add those together, I get 14, 19, 20, 25. So there are 36 in year 5 and 25 in year 6. So the number that's going to be on the bottom of this will be the sum of 35 plus 25. Now on the top, no more than 1 pet. So I can do that easily for year 6. It's 6 and 8, which is 14. So I've now just got to get this bit of information from the pie chart. Now, for the pie chart, I know that the pie represents 36 people, and I know that that angle represents the number of kids with no pets or 1 pet. So I need to measure that angle. So you get your angle measurer, you put the center of the angle measurer on the center of the pie, and you line the 0 up with one side of the angle you want to measure. And then you bring your marker down to read off the other side. So the other side is 130 degrees. Okay, there'll be 1 mark for you having correctly measured that angle. So we've got 130 out of 360 times 36. Okay, so the fraction that that angle represents out of the whole pie is 130 out of 360, and then we want to work out how much of that, how much of 36 you get from that fraction. Now it's a non-calculator question paper, so I can see there that straight away I can divide both of those by 10 because they both end in a 0. Then I've got 36 divided by 36, so that leaves me 13 times 1 over 1, which is 13. So that represents 13 pupils. (13 plus 14 is 27. 35, sorry, that should be 36, shouldn't it? 36 plus 25 is 61. Okay, so there's 1 mark for measuring the angle. There's a method mark for then working at setting out what fraction of the class are going to have no more than 1 pet, and 1 mark for getting 13. There's going to be 1 mark for working out this 25 in year 6, and then 1 mark for the top value and 1 mark for the bottom value. 1, 2, 3, 4, 5, 6. Another way you can consider this is if you've got 360 degrees that you've got to share between 36 students to see how many degrees each student gets. Okay, so 360 degrees shared between 36 pupils. So each pupil gets 10 degrees, 360 divided by 36, and you've got 130 degrees, so 130 degrees, each pupil gets 10, will be 13 pupils. Okay, so if you don't like cancelling fractions, you can figure it that way. The whole pi represents 360 degrees, and the whole pi represents 36 kids. So each kid is 10 degrees of the pi. And for 130 degrees, that would be 13 pupils. Question 4. A and B are independent events. The probability of A occurring is 0.6. The probability of event A and event B occurring is 0.48. Complete the T-tree diagram. Now this is one that when we practiced these before Easter, I pointed out was the sort that you need to be a bit more careful about. Okay, so you see this and you see the probabilities, and you know that these two branches must add up to 1, so that's going to be 0.4. The most common mistake to do then is to put that 0.48 there and then work out the others from there. Look at that, that's worth more marks than you normally get for just completing the diagram. And that's because that is not 0.48. What comes out the other side of travelling along there and there equals 0.48. So what you've actually got to do to work out that is 0.6 multiplied by that equals 0.48. So you've just got to rattle through your 6 times table and notice that 6/8 are 0.8. So the question mark is 0.8. Once you know that's 0.8, well, that must be 0.2 because they've got to add up to 1, and then this branch is repeated. So you're going to have 1 mark for putting the 0.4 in the right place, a method and an answer mark for working out that that is 0.2, and then the final mark for correctly filling in all the others. Calculate the probability of neither event A nor event B occurring. So that means A doesn't occur, and it means B does not occur. So I'm travelling in the same direction through my number line. So A does not occur and B does not occur. If you're using the word and, you multiply. If you're travelling in the same direction on a probability tree, you multiply. So that will be 0.4 times 0.2. 4 2s are 8, and there are 2 digits after the decimal points in the numbers you start with. So that means there'll be 2 digits after the decimal point in the final answer. So it's not 0.8, because 0.8 would be double that. It would be 0.4 times 2. So 0.4 times 0.2 is 0.8. M1 if I see 0.4 times 0.2, A1 if you've correctly multiplied. In the diagram, AB and ED are parallel. Triangles ABC and DEC are similar. That's the trigger. This tells you that this is a question on similar shapes. Now, we practiced similar shapes before the numeracy paper. With similar shapes, you have to work out what the scale factor is between the two shapes that you're given. And on the numeracy papers, that was straightforward because you could work out very quickly what the corresponding sides were. It's a bit trickier in this one because you haven't got any shapes. You need to figure out what sides correspond to what. And to do that, you need to figure out the angles. Now, where the two lines intersect at the middle, that means that the opposite angles are the same. So that angle is the same as that angle. Then we've got to figure out which of these is the same as which of those? And that comes from the parallel lines. You've got a Z angle there, so that one is Zing with that one, which means A, which I'll put 3 curves on, corresponds to that one. So when we now need to figure out what's what, I've got my ABC triangle, C at the top, 1 hoop, B there, 2 hoops, and A there, 3 hoops. So with the bigger triangle, top is obviously C, the 2 hooper is E. So E has to be there, and A then D will be there. So BC is 8, AC is 10, DC is 15, and ED is 10.5. To work out the scale factor, you are looking for a pair that correspond, so AC and DC. So you're basically saying, right, what have I got to multiply that by to give me 15? And that's my scale factor that then would multiply every other side up. So scale factor is 15 divided by 10, which is 1.5. So every side in the bigger triangle is 1.5 times the side in the smaller triangle. So for CE, I've got to do 8 times 1.5. 8 times 1 is 8, times a half plus a half of it will give you 12. And then for AB, I've got to shrink. So for AB, rather than multiplying by the scale factor, I've got to divide by the scale factor. So that's the same as 1,505 divided by 15. I don't know my 15 times table, so I'm going to guess 5. So 5 times 15, 5 5 is 25, 1 5 is 5. What have I done there? 5 5s are 25, 1 5 is 5 plus 2 is 75. That's too small. I'm looking for 105. I'm going to try 20 lots of 15. Sorry, what am I doing? No, I'm not. 20 lots of 5 is 100. What am I trying to do here? 10, sorry. 10 lots of 15 is 150, so it's less than that. So let's try 9 times 15, 45. 1 9 is 9, 10, 11, 12, 13. That's 135. So let's try 7 lots of 100. Oh God, 7 lots of 15. 7 5s are 35. 1 7 7 and 3 105. So it goes in 3 times. So if you can't divide and you don't know your times table, you just work it, pick a value, work it out. Do I need to be bigger? Do I need to be smaller? So that is that. So you've got M1 for finding the scale factor and an answer for 12, and then M1, A1, same, dividing to shrink it, and your answer mark. Question 6, simultaneous equations. Hopefully you're getting used to these by now. So the method is, you label your first pair of equations 1 and 2. You multiply the first equation by the value in front of the x in the second. We want to make the x's the same so that we can eliminate them. So equation 1 times 5, so I have to multiply every value there by 5. 10x plus 15y. 29 times 5, not sure, I'll do it over here. 5 9s 45, 2 5s are 10, 145. Call that equation 3. And then equation 2, I'm going to multiply by 2. the number in front of the x in the first equation. 10x minus 8y minus 16. So every one of those I've multiplied by 2. That's equation 4. Now, the reason I've done that is I want to get rid of those 10x's, and I'm going to do that by subtracting. I'm going to take equation 3, top one, and take this one off it. So I've got 10x take away 10x, 0, gone. With this one, you've got to be very careful because you're subtracting a negative number. What you're actually doing is 15y take away minus 8y. Minus minus makes a plus. So you got 15y plus 8y, which is 23y. So those two make 23y. And then similarly here, I've got 29. No, I haven't. I've got 145 take away a negative 16. Sometimes those values are positive and it's just normal, but if you're subtracting a negative number, you've got to be careful. So that's going to be 145 plus 16, which is 61. So I've done that and it's got rid of the x. So now I've got an equation which has just got the y as an unknown. So now I'm going to do 61 divided by 23 to get the y on its own. How many times does 23 go into 61? And I'm going for 7 because 7 3s are 21, so let me just check. 23 times 7. 7 3s are 21. 2 7s are 14, 15, 16. God, what have I done then? It's been a long day. What have I done there? It's not 161, 23. What have I done? So we've got, let me just go back through what I did this morning. I can't see my mistake. Oh, it should be 161 there, that's why. Not 61. 445 plus 16 is 161. 161 divided by 23 is 7. So y is 7. So that's the first value, but we need to work out what the x value is as well. So what we now do is choose one of our equations, and I'm going to choose number 1 because number 2's got nasty negatives in it, and I'm going to replace the y with 7. So 2x plus 3, and then instead of y, 7 equals 29. 2x plus 21 equals 29. Take 21 off each side and you get 2x equals 8. Now this time it isn't minus a minus number because I'm just doing 29 take away 21. X will be divided by 2, 4. So y equals 7, x equals 4. 4 marks for that. Seems a lot of work for 4 marks, but the method is quite easy to get into. So M1A1, method for getting an eliminator. So eliminating the x to get to there, A1 for getting 7. And then the same for the second part, M1 for getting rid of the y in an equation, and A1 for getting x. Question 7. Circle the correct answer for each of the following statements. 7 meters cubed is equal to. Right. And we're turning it into centimeters cubed. So 1 meter is 100 centimeters. So if you've got a meter cubed, that's going to be 100 times 100 times 100 centimeters, which is 1 followed by 1, 2, 3, 4, 5, 6 zeros, which is 10 to the 6. So 7.2 meters is going to be 7.2 times 10 to the 6 centimeters cubed. So that one. 36 to the power of a half. The number on top of the index is just the power, which is 1. The number at the bottom is the root. So this is the same as the square root of 36 to the power of 1. Square root of 36 is 6. 6 to the power of 1 is 6. Find the value of, write your answer as a decimal. So we're dividing, when we multiply or divide, it's easier to do with the numbers in standard form. So let's turn the 30,000, decimal point, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, and so on, into standard form. So 30,000, it's got 4 zeros, 1, 2, 3, 4, and then a 3. So 30,000 is 3 times 10 to the 4. So that becomes 3 times 10 to the 4 divided by 1.5 times 10 to the 5. When you're multiplying or dividing, deal with the number parts. So 3 over 1.5 times 10, and then deal with the powers. You're dividing here, so you're going to be subtracting the powers. 3 divided by 1.5 is 2, and that is 4 take away 5, which is 2 times 10 to the minus 1. So you're going to have a method mark there for whichever way you've done it. You could have turned that into a number first, if that's the way that you decided to do it, or turn that the other way, and then your answer mark, whichever way you've gone about it. Oh, I know. Give your answer as a decimal. So they don't want it in standard form. 2 times 10 to the minus 1. So back up here, minus 1, minus 2. The 2 is there. So 2 times 10 to the minus 1 as a decimal is 0.2. So the answer is for that. So in fact, what you've got there is a B1 if you've ended up with 2 times 10 to the minus 1 using whatever method, and a B1 for the 0.2. Question 9 you can't do. Where are we going now? Question 12. Enlarge the triangle below by a scale factor of -2. Use the origin as the centre. So we're starting there. And it's a negative scale factor. That means we reverse the movements that we're going. So to get from there to there, we're going up 3, left 1. Up 3, left 1. That is going to become down 6, right 2. So we're reversing the motion and doubling the size. So back to the origin, down 6, right 2. So that one ends up there. This one would be up 4, left 1. That would become down 8, right 2. So that's my circle. And then my plus will be up 3, left 4. So up 3, left 4 will become down 6, right 8. 1, 2, 3, 4, 5, 6, 7, 8. So those are my 3 vertices, my 3 corners. That's my shape. So there'd be 1 mark there if you've enlarged the triangle with a scale factor of 2, and 1 mark if you've correctly used the negative scale factor. Question 13. 6 marks for this. It's quite a complicated forming an equation. So it's grade A. See how you follow this. Marion is competing in a race. The race is 6x plus 5 meters long. She completes the race in x hours. Her average speed during the race is 2x plus 3. Calculate how long Marion takes to complete the race. You must use an algebraic method, not trial and improvement. So I'm seeing average speed. And you know that speed is distance over time. So the average speed is 2x plus 3. The distance is 6x plus 5. And the time taken is x. Okay, we need to get rid of that x from under there, and we do that by multiplying by x. If we multiply that side by x, it'll cancel with that, and I have to multiply that side by x as well. So I end up with x bracket 2x plus 3 equals 6x plus 5. Now I can multiply out my bracket, and I get 2x squared plus 3x equals 6x plus 5. All we're doing there is multiplying throughout by 1. There's no number there, it's a 1, not a 0. 1 times 6x is 6x, 1 times 5 is 5. Now, I can see that I got an x squared term, some x's and a number. I'm thinking this could end up a quadratic equation, and to do that I want everything equal 0. So I'm going to take that 6x off and take that 5 off, which means I can do the same this side. And what I'm left with then is 2x squared plus 3x minus 6x is minus 3x minus 5 equals 0. So now I can see I've got a quadratic equation which I need to try and factorize. It's not using the formula because A, it's a non-calculator paper, and it's not telling me to give my answer to 2 decimal places. So I multiply these 2 bits together and I get minus 10. I list the factor pairs of 10, and it's 1 and 10, 2 and 5, 5 and 2. I can stop. I need to make negative 3. I can't do it out of that, but I can with this one if I got a plus 2 minus 5. And I'll rewrite this, and instead of minus 3x, write plus 2x minus 5x minus 5 equals 0. You work with the first pair. What can you take out as common? 2x. What would that leave? X plus 1. 2x times x is 2x squared. 2x times 1 is 2x. For the second one, I know that the repeated bracket has to be x plus 1. I can take 5 out, and if that was a plus 5, I'd end up with plus 5x plus 5. It's got to be negative. Minus 5 times x is minus 5x, and so on. I got a repeated value of x plus 1, leaving me 2x minus 5 equals 0. Then I say, well, either this has to equal 0, and that would give x equals minus 1. Now x can't be minus 1 because it's a time. or 2x minus 5 equals 0. Add 5 to both sides, divide by 2. 5 divided by 2 is 2.5. Can't be negative, can't have negative time. So x must be 2.5 hours. So takes 2.5 hours to complete. Okay, so you're going to have M1 for forming that equation. You're going to have A1 for getting rid of the fraction. You're going to have A1 for forming the quadratic equation. You're going to have M1 for your method of solving the quadratic, and A1 for factorizing it, and then the final A1 for your 2.5 hours. 1, 2, 3, 4, 5, 6. Question 14, indices. Let's make this a bit bigger. So here we are again. This is the power. This is the root, so it's going to be a cubed root. And this is reciprocal. So this means 1 over the cubed root of 125 to the power of 1. The square root, the cube root of 125, you're looking for what times itself 3 times gives you 125. I mentioned this on a previous video. You're not required to know many of them. 1 times 1 times 1, 1. 2 times 2 times 2, 2 twos are 4, 4 twos are 8. 3 times 3 times 3, 3 threes are 9, 9 threes are 27. 4 times 4 times 4, 4 fours are 16, 16 fours 64. 5 times 5 times 5, 5 fives are 25, times 5, 125. So that's going to be the cubed root. So 5 is the cubed root of 125. So it's 1 over 5 to the power of 1. Anything to the power of 1 is itself. And finally, question 15, surd. Okay, so square root of 800. I need to write that, simplify that. So I can write that underneath as 100, which I know is a square number, times 8. So that's going to be the same as the square root of 100 times the square root of 8, which is 10 root 8. But 8 I can write as 4 times 2, where 4 is a square number. So that's going to be 10 times the square root of 4 times the square root of 2. Square root of 4 is 2. So that's going to be 20 root 2. So root 800 I can write as that. Root 2 cubed is going to be root 2 times root 2 times root 2. Root 2 times root 2. If you're multiplying a root by itself, you just get the number that's underneath it. 2 root 2. So 800 divided by root 2 cubed is the same as 20 root 2 over 2 root 2. The root 2's cancel and 20 divided by 2 is 10. So that bit is rational. It's 10. Now I need to look at what happens with 3 minus root 7 squared. Means you're going to multiply it by itself. 3 times 3 is 9, minus 3 times root 7, minus 3 times root 7, plus root 7 times root 7, plus because I got a minus times a minus. 9 minus 6 root 7 plus root 7 times itself is 7. So you've got 9 plus 7 is 16 minus 6 root 7. So this bit is 10. This bit is 16 minus 6 root 7. So that's going to be 26 minus 6 root 7. You can't simplify it any further. The answer has got a root in it, which means it's irrational. So that was work we did around about the same time as surds on rational and irrational numbers. An irrational number is a number you cannot write as a fraction of whole numbers. So 5 marks for that. You're going to have B1 for dealing with the root 800, B1 for dealing with the 2 root 2, the 2 root cubed, and B1 for working out that that is simplified to 10, B1 for squaring that, and B1 for then confirming that it's irrational. And that is it. There are no other questions on that paper that we've covered the work. Okay. And probably the surds is the hardest stuff that you've got in there.